Hey guys! Welcome back to my channel. In this video you will learn about how to write half equations and overall redox equations. But before that we make sure to subscribe to our channel and turn the notification on, so you don't miss any videos in the future. Redox chemical equations can become quite complicated because of the number of chemical species involved. Thus for this very same reason redox equations are balanced in two half equations. The oxidation half equation and reduction half equation. And then when the equations are combined and electrons are cancelled, the overall chemical redox equation can be written. The oxidation half equation demonstrates atoms losing electrons. However, the reduction half equation demonstrates gaining electrons. In general, half equation can be defined as equation that represents either an oxidation or reduction half of a chemical equation. It also includes electrons to demonstrate the transfer of electrons. Here is an example of how to write reduction and oxidation half equation. In this reaction, copper 2 plus sulfate reacts with zinc metal. Assign oxidation states to identify chemical being oxidized and reduced. In this reaction, as you can see, the compound of copper sulfate is showing that it doesn't have a charge and is neutral. The question has been given copper as +2 charge. As such, if the compound is without charge and completely neutral with copper 2 plus charge, thus we can say that sulfate has oxidation charge of -2, which they cancel out each other and causing the compound to have a neutral charge. On the reactant side, zinc is shown as monoatomic solid metal. Monoatomic ions, the oxidation number is always given. Therefore we can say that zinc has charge of 0. On the product side we can see that zinc sulfate has been formed. In this compound the charge is not given. Therefore it is neutral and has charge of 0. For this reason we can tell that both atoms should have the same oxidation number, which cancels out each other and remains the compound with no charge. As such we can tell sulfate has charge of -2. And zinc has charge of +2. This shows it has been gained 2 electron. Therefore it has been reduced. As such we can see that copper has lose 2 plus charge. Therefore it has been oxidized. Both copper and zinc are participating in this reaction. It is because they both change oxidation states. Sulfate remains unchanged in both sides of equation. Therefore we can tell it is an spectator ion. Spectator ion is defined as an ion that exists in the same form on the reactant side and product side of redox equation, which show no change in its oxidation state. Therefore we should ignore sulfate when writing half equation. As we stated, it boasts that copper is reduced. Therefore we should write reduction half equation. To balance this equation, the charge on the right side is not given and is not equal to the other side. Add electrons to left side of the equation. We should consider that copper has 2 plus charge, therefore when adding electrons we should give 2 electrons. The reason we added electron in the left side was because they are negative and it can cancel the copper 2 plus charge. And balance both sides of equation charge. If we were writing 2 electrons on the right side, the equation wouldn't be balanced, and this is because on side will be -2 plus charge and the right side will have +2 plus charge. On the other side the oxidation of zinc increases from 0 to +2. Therefore we add 2 electrons on the right side of the equation to balance the charge in both sides of the equation. Then we should combine the two half equations. To do this, both half equations should have the same number of electrons. If it does not have, we cannot write the overall redox equation. In this equation the electrons will be cancelled out. Thus it will give the overall redox equation. Note that when combining half equations, if they do not have the same number of electrons, we should ensure that they have the same number of electrons. For this we should multiply the coefficients of the electrons in both equations if the charges are not balanced. Here is another example to write the oxidation and reduction half equations. Feel free to pause the video and give it a try. The first step is to assign oxidation state to identify the atoms that have been oxidized and reduced. Monoatomic ions in the reaction has no charge. It includes iron and hydrogen gas. Hydrochloride compound is given neutral and it does not have charge. As such it shows they both have the same charge, which then is being cancelled out to form the compound. Hydrogen is in group 1. Therefore it has charge of +1. Thus we can tell that chloride has charge of -1. On the product side we can see that chloride has been stayed the same oxidation state. Therefore we can tell that it is an spectator ion. However, hydrogen is being oxidized as it has been lost electron. iron has been gained 2 electrons. We can tell this as it shows that small 2 on the bottom right of chloride atom. Therefore As has been reduced and gained electrons. Writing reduction equation for iron. We should add 2 electrons on the product side to balance the equation. For oxidation half equation for hydrogen. As it has been loosed 1 electron. We should add -2 electrons on the right hand side. Note that we have been said that hydrogen has been loosed 1 electron. However we added 2 electrons. This is because the coefficient of 2 on the hydrogen side will be multiplied by the charge, which gives +2 charges to the atom. At final step, combine the 2 half equations. Then cancel the electrons, which gives you the overall equation. Keep this in mind that electrons had the same number in both half equations. That is why we do not multiply these equations, because they have the same number of electrons. The key information that you should remember from this lesson is that before writing half equations for any chemical reaction, we should balance them first, or ensuring that they are balanced, was the lesson for today. I hope you have learned something new today with us. Thank you for watching my video.